Hey y'all, in this video we're going to be covering the 3 foldables on this next page. So we've got our using zeros to write polynomial functions book. We've got a foldable about multiplicity, and we got a book about complex zeros. Okay, let's get to it. This first part, you do not need to write this down. So those of you who are listening with the audio on, you heard that. Everybody else is going to get confused. Using zeros to write polynomial functions. So normally polynomial functions would look like x squared plus 4x plus 5. But we know we can rewrite this in factored form. This one would be like x plus 5. Oops, this one actually won't work. Let me change it. We'll make this one a negative 5. Maybe, if my pen wants to work. Okay. So this would be this. So we've got standard form, factored form, and factored form helps us find our zeros through ZPP. And ZPP we just do x plus 5 equals 0, x minus 5 equals 0, and x equals negative 5, and x equals, oops, I don't know why I wrote this one right there. That should have been minus 1 along both sides. So if I've got my zeros, we've been solving from standard form and then finding our zeros. These notes today are going to tell us how to go from here back to that. Cool. So let's get into it. The first page. This is saying that our zeros are at x equals 1, 2, and 5. So we can rewrite those all out. We're just working backwards through those steps. So from here to this step, we're going to write x equals each one of them individually. X equals 1, x equals 2, and x equals 5. So we're going to solve each one of these by working backwards. So we're going to minus 1 and get x minus 1 equals 0, x minus 2 equals 0, and x minus 5 equals 0. Now that they all equal to 0, we can multiply them together. Alright, we're in factored form. Now to put this into a polynomial, we're going to multiply all these out. So be very careful when you do this. Don't go too quick or else you can screw up some positives and negatives. So go slow. This first one, I'm going to FOIL it because that's what makes more sense to me. If you want to box it, you can. X minus 5 now equals 0. So now I've got to multiply this trinomial by the binomial. At this point, FOILing might get kind of ugly, so now I'll go into a box. This is going to be a 2 by 3 box. Cool. Normally the like terms are going to lie on the diagonals of the box, so those combine, and these combine, and then the other two just chill. So we're going to be having x cubed minus 8x squared plus 17x minus 10 is our final answer. So we worked entirely backwards. We went from having just zeros and we worked it into having the whole equation written out. Okay, I'm going to skip, whoa, Question 2, I want you to do question 2 on your own. Okay, I'm going to do question 3. We're going to set it the same way that we did last time. So those are my zeros. I'm going to write this as x equals -2. X equals, I'm going to keep this negative to that top one, -4/3, and this one's going to be x equals 2. Let's start solving. I'm going to add 2 on both sides, giving me x plus 2 equals 0. This middle one I'll do next. This one's going to be -2 minus 2, x minus 2 equals 0. This middle one takes 2 steps. So the first thing we got to do is multiply both sides by 3. Giving us 3x equals -4. And then we're going to add 4 on both sides. Getting us 3x plus 4 equals 0. Now we have all of our factors, so we're going to write it out as one long factored form. I'm going to move this one in front. X minus 2, 3x plus 4. So you're going to multiply the binomials together. This one's nice because it's going to be a difference of squares because we have the same thing written twice, but the signs are different. So if you know your difference of squares, this is going to be rewritten as x squared minus 4. Then bring down this next one. And if you didn't see this step, you can always FOIL it or box it, and you'll see that you're going to land up with that same answer. I'm going to do a box. And that one's done. Let's do number 4 together. Actually, between 4 and 5, I think I'm going to do number 5 because it's a little bit more complicated. This one is just saying 0. Maybe it'll let me do it. Jeez. 0 plus that. I'm going to do the one that has a number in front. So question 5. This one looks like x equals 2 radical 3, x equals -2 radical 3, and, oh gosh, x equals 1, x equals -1. So if I were to write all these factors out, I'm going to minus 2/3, or 2 radical 3s. X minus 2 radical 3 is my first factor. This next one's going to be x plus, oh, skip the 2, 2 radical 3. And these ones are going to be x plus 1 and x minus 1. In the previous problem, I talked about our knowledge about difference of squares. If we have the same thing written, but they have different signs, there's this rule that says, you don't have to do this next part. I'm just going to do like some side notes. X squared minus y squared is going to give you x plus y, x minus y. And so in here, this is going to give me x squared minus whatever this term is squared. So this whole piece times 2, or sorry, times itself. So this is like 2 radical 3 to the power of 2, which I know is x squared minus 4 times 3, which would be 12. If you don't believe me, scratch work. 2 radical 3 times 2 radical 3. 2 and the 2 become 4. The radical and radical 3 become radical 3 squared, or just 3. 4 times 3 is 12. Okay, so this next part, just going to bring it down, is going to become x squared minus 1. Now I just have two binomials to multiply. Squared plus 12. Final answer. Let's do number 6. You might want to write small for this one. This one's going to take a little bit of work. So we get x equals negative 6, x equals 2 plus radical 5, x equals 2 minus radical 5. So for these ones, I'm just moving everything over so that eventually it'll say equals 0. And now I'm going to multiply everything out. I'm going to multiply these ones first because there's 3 things being multiplied to each other. So this is going to be a triple box. So these combine. I'm going to put it in red, the ones that disappear. So like this goes away. Oop, that's not good. Hold on. Let me do it in orange instead. That goes away, that goes away, that goes away, that goes away. And now our final piece is going to be x squared minus 4x. And then I've got this 4 and this negative 5, which gives me negative 1. So that came from, this piece came from multiplying these two. Now I got to bring this guy down. Ooh. And that's the final answer. Okay. So for this first handout, you're doing question 2. You didn't really need all this side work anyway. Oh, I lost my pink highlighter. Cool. And so that's for the booklet. Now let's do some examples that have multiplicity. Multiplicity we've talked about in class before. That's when the graph either touches it once. Try that again, a little bit neater. Then bounces away. We have an example where it passes through. Or an example where it doesn't touch it at all. So multiplicity, this is if it's an even. Odd. And this one, there wouldn't be an example. There basically would not be a 0 because there's no x-intercepts. Okay, so I'm going to do, let's see. Let's do this first one. Multiplicity of 2 tells you what your exponent's going to be. So this originally was x equals 3 and x equals 5. But now we're going to move the 3 over and get x minus 3 as a factor and x minus 5 as a factor. The only thing that's different is that this multiplicity of 2 tells you that that 3, it has a bounce at 2. So what we really have is x minus 3, x minus 3, and an x minus 5. And we solve. This much becomes x squared minus 6x plus 9. Bring down your x minus 5. X minus 45. That's the polynomial for that first problem. Again, we're on a different handout now. We're on the multiplicity handout. Cool. You're going to do this one. Remember, be careful about this. You're going to do x equals 5/4. You're going to times 4. And then you're going to minus 5. Okay, so I'm going to erase all of that because this is something that you're going to do on your own. You want to get your final polynomial. All right, let's do this next one. So this is like x equals 0. I can move 0 on the other side, but it's still going to be x, so it's almost like x as its own factor. This one is going to become x minus 1 as a factor. This one will become 2x minus 5 with a multiplicity of 2. So I'm going to first just distribute this x to everything. And that power of 2 just means that you're going to write it twice. And then you could FOIL it, you could box it, do whatever you want to do, but you're going to get 4x squared minus 20x plus 25. Now from there, I would probably recommend doing a box. And that's your final answer. Okay. You are responsible for this one. Cool. All right, last bit. What happens when your zeros are in the complex number system? So for this one, if a polynomial function has a complex zero at a plus bi, then its conjugate a minus bi is also a solution. Okay, so let's open this one up. You can say also a solution, or you can say a complex zero. Cool. Let's do now this is a complex solution, which means I also have to include its negative. So I'm going to have x minus radical 6 times x plus radical 6, x minus 2i, and x plus 2i. And we multiply by through. So again, these are like difference of squares. So this is going to wind up being x squared minus whatever square root of 6 squared is, which we know with the deduct principle just becomes 6. Another way of thinking about this one, you don't have to do this, just look at the example. If you have x equals square root of 6, this piece, you can square both sides, get x squared equals 6, and then minus 6 on both sides. That's another option. But if you don't want to do it that way, don't worry about that way. You just do it the way I originally showed you. Yay! This next one, same deal. You're going to have x squared minus 2i squared. What is 2i squared? That would be 4i squared, or 4 times negative 1. So I'm going to take this and put a negative 4. Cool. Now I've got two binomials to multiply to each other. You can do a box method or FOIL. Sometimes when I've got, actually no, this one you could probably do in your head. You don't need to do a box. You would get x to the 4th and negative 2x squared minus 24 would be your final answer. But go for it, do the box if you want to do the box. Okay, let's do this next one. Try and do the harder ones. I'll do these last two. And now if it includes its negative, you also got to include its positive version. So we're going to have x equals I. So when we do this first one, we are going to get x squared minus 20. And when we do this next one, we'll get x squared. It'll be minus I squared, but we know that I squared is the same thing as negative 1. If we have a negative 1, we really have great. And that one's done. Last one. We got x equals negative 4, x equals 3 plus I, x equals its conjugate, 3 minus I. Now we will subtract everything over, so this is going to become x plus 4. This one, I'm going to subtract the 3 and the I. This one, I'm going to subtract the 3, but I'm going to add the I. I like to start with the longer ones first, so this one, I'm going to put it in a box. And I can combine this 9 with that positive one. So everything here in blue becomes x squared minus 6x, 9 and positive 1 become 10. So got that. I'm going to bring down the first part. Minus 14x plus 40 is my final answer. Cool. Alright, so now you only have to do this one. Great. So everything we did today, quick review. Using the zeros to write polynomial functions, that's when we work backwards through this process. Just a reminder, you did not have to do all of this. So you didn't have to copy all that down, but it's good to review. If you're given the zeros, set them equal to x, do reverse ZPP to get it equal to 0, and then you have your factored form, and then you just multiply factored form into your polynomial form. That's what this one was about. Our examples with multiplicity is just saying what happens when that 0 happens multiple times. So, for example, this 2x minus 5 happened 2 times, so I wrote it twice. And then complex zeros, the only thing you have to remember is that whatever they give you, you also have to take their conjugate, which could mean you've got maybe like 3i. That means not only positive 3i, but you also have negative 3i. If you had 2 plus 7i, you also have the negative version. So that's what